Spring data access or persistence. These are the set of topics we are going to cover in this presentation and lab session. We'll talk about the DAO support in Spring Framework. Sometimes we use the term repository. So in this presentation, we are going to use these two terms, DAO and repository, interchangeably. By the way, DAO stands for Data Access Object. We'll talk about repository annotation, and then we are going to see how we can access data through three different technologies. Well, actually two different technology in this presentation. First, using JDBC. So we're going to take a look at the JDBC template class, and then there is a named parameter JDBC template class. So this is the class that we are going to work with in our lab session. And then we are going to see how we can access data through OR mapper, especially JPA. We are not going to talk about Hibernate API anymore because it's fading out, and the JPA API is definitely in favor. So we're going to mostly focus on JPA. One more data access technology is called the Spring Data JPA. Here we are going to, we are not going to talk about this one. We are going to actually have a separate session today covering Spring Data JPA. In fact, Spring Data JPA is a new and recommended access technology for relational database moving forward. Let's talk about DAO support. So DAO stands for Data Access Object. So basically, DAO support in Spring is providing consistent and portable code, regardless of what technology you are going to use underneath. So again, the technology you could use include JDBC, Hibernate, JPA, JDO, whatever data access technology. But idea is that by having DAO layer, you are abstracting out data access so that your upper level application can be shielded from the talking to database directly. So it provides the portability of code. In fact, switching to different persistent technology, for example, from JDBC to JPA and JPA to something else, is a matter of changing few lines in the configuration file. And it also handles exceptions, and we're going to talk about that in the following slide. The problem of using a low-level APIs of JDBC, JDBC, for that matter, is without using DAO directly is, I'm mumbling a bit. So as I said, DAO is actually providing abstract layer, and instead of using DAO, you could actually go a low-level API such as JDBC. And one of the problem of using low-level API is that you are stuck with the low-level exception handling as well. So that's something we're going to actually talk about in the following slide in a bit more detail. Okay, so that's what I meant here. Consistent exception hierarchy is provided by Spring data access technology. For example, Spring provides its own data access exception class hierarchy, and data access exception is a root exception. So basically, Spring will translate low-level exceptions such as SQL exception to its own exception class hierarchy. So regardless of what persistent technology you are using underneath, your application will deal with the Spring provided exception classes, which is providing portability of the application. Spring provided data access exception. It also has a reference to original exception. So if you need to access original exception object, you can certainly do so. Okay. So this exception hierarchy is handling any low-level data persistent technology, including JDBC and Hibernate and JPA. By the way, when I'm saying lower layer, I'm talking about lower layer than DAO layer. Okay, so this slide shows class hierarchy of data access exceptions. So as you can see, there is a data access exception, which is a root class, and then we have a bunch of other exception classes in Spring. Again, all these exception classes are supposed to be usable. They are usable over any persistent technology, Hibernate, JPA, JDBC. Okay, so let's move on to repository annotation. So repository annotation is used with DAO classes, data access object classes. So as I said before, DAO class or DAO layer provides an abstract layer for persistence mechanism so that your application are shielded from accessing the database directly. By the way, as I said before, we are starting to use the term repository as well to refer DAO. So again, you can think of DAO and repository are the same thing. By using repository annotation, you are indicating to Spring Framework that your DAO layer should have Spring data access exception hierarchy. Okay? So meaning Spring should translate low-level exception to Spring data access exception classes. And as we talked about in the beginning of this code camp, repository is a stereotype of component, meaning special stereotype of component. So you should be able to use repository for your DAO classes, and that could be automatically scanned by the Spring Framework. Okay, so suppose if you have some movie finder DAO class, and if you annotate it with repository, and then if you perform auto scanning, this class will be detected by Spring Framework dependency injection. Okay, so access to persistent store. So all DAO implementations need to have an access to persistent resource. So persistent resource is representing a particular technology data resource object. So for the JDBC based repository, we'll need to have an access to JDBC data source object. And Hibernate based repository will need to have an access to session factory. And JPA repository need to have an access to entity manager. So, for example, JPA applications, you have to have an entity manager object, and this entity manager object will provide an API. So, like it provides methods for performing database operations, for example, like a save or find and things like that. And same thing with the session factory for Hibernate. Sorry, oops. Okay. All right, so the easiest way to accomplish is to use a dependency injection. So you could use AutoWired for JDBC data source and Hibernate session factory. And for JPA entity manager object, JPA specification indicates that you should use persistent context annotation rather than AutoWired. So we are going to actually follow that specification. All right, so let's take a look at an example of this. So this is an example where we are using JDBC template. By the way, JDBC template is high-level convenient utility class that is provided by Spring Framework. We're going to talk about the advantage of JDBC template utility class over low-level JDBC APIs. It actually provides a lot of the useful features. So here you are getting data source object injected by using AutoWired. Okay, so when you create JDBC template object, you have to provide this data source object. Okay, and once you got the JDBC template, then you can actually perform database operations invoking methods that are present in JDBC template. Okay, yeah, we are going to see all these things in our hands-on lab. So if you're not quite sure how things work, yeah, we'll certainly dive into these things in detail. Okay, so Hibernate, you have to have session factory object, and session factory object is the one that you have to perform database operations. Again, session factory is providing bunch of data access operational methods like a save and update and things like that. For JPA entity manager, so the Hibernate is a session factory, and basically we have entity manager in JPA. So as I said, in order to get the entity manager injected, you need to use @persistent context annotation. Again, the reason we are not using AutoWired here is because the JPA specification says that in order to get entity manager, you have to use @persistent context annotation. Okay, so in order to get the, so that's the way we are going to get the entity manager object. Okay, so we are going to actually start with data access with the JDBC, and then we're going to actually move on to Hibernate and JPA. In fact, we are going to actually skip Hibernate because, as I said before, the Hibernate API is not really being used anymore. So we're going to mostly focus on JDBC and JPA APIs, at least from API standpoint. Okay, so let's talk about the JDBC. So Spring JDBC provides high-level abstracted classes like JDBC template, and so it actually has a few advantages. So you take care of all the low-level plumbings, and the only thing you have to deal with is, for example, the define connection parameters and specify SQL statement, and declare parameters and provide parameter values, and then do the work for each iteration. And the low-level plumbing work will be performed by Spring Framework, the JDBC template classes. So, for example, opening a connection and prepare to execute the statement, and set up loop to iterate through the results, and process exception, handle transaction, close the connection, and all those things. Those are all plumbing work that could be handled by Spring Framework JDBC template utility classes. Okay, so options to choose for JDBC access. So you can use, I should actually say, two flavors, because one of the JDBC class, simple JDBC template class, is deprecated. So I actually removed it from the slide this morning. So I should say just two flavors: JDBC template or named parameter JDBC template. We are going to mostly focus on named parameter JDBC template in our hands-on lab exercise. And there are also simple JDBC insert and simple JDBC call. So simple JDBC insert simplifies insert capabilities for the table, and simple JDBC call is for calling stored procedures. And then there is also what is called the mapping SQL query and SQL update and stored procedure. So these are all high-level the APIs that are provided by Spring Framework to make your life easier when you are dealing with the JDBC. Okay, so let's talk about JDBC template class. So as I said, it provides high-level API than raw JDBC calls. So it handles creation and release of resources, so that you don't have to actually deal with it, and it can handle common errors such as not closing the connection and things like that. Okay. And then it provides APIs, meaning the methods for execution of SQL queries, update and calling stored procedures, and perform iteration of a result set and extraction of returned parameter values and things like that. Okay, so let's see examples of the methods you can call in JDBC template. Okay, so these are examples. So here, suppose we got JDBC template object, we can perform query operation. So you can see, if I want to get the number of rows, so I can call query for int method from JDBC template class, and then you provide the SQL statement here. Okay, and then it returns the number of rows as int. Okay, so this is a lot more convenient than using low-level JDBC call. This one is simple query using bind variable, so we can actually have this, the question mark, which is going to be replaced by this argument value. So we have SQL statement where the question representing a particular variable will be replaceable by the values over here. You could have a multiple question mark here, and then you can just specify the set of arguments that will replace these variables. Querying for strings. So if you want to receive the data in string format here, so basically in this case, you're going to use query for object, and then you provide SQL statement here, and then here you can actually provide arguments in a form of an array. So we have a single item here, so that's the reason we have provided only a single value 1212L, and then this is the required type or return type you want. Okay, so basically what you're saying is that perform this SQL statement, okay, using these guys as replacement of these the variables, and then the return type I want to receive the value is the string type. Okay, so the result will be converted into string type, and then it will be returned to the last name variable. Okay. You can use update method to perform insert, update, and delete operations. Okay, so this is the case that we are using update for insert operations. So basically, you are going to provide SQL statement with the insert and the insert and update and delete. But in terms of the actual method, we are all using update method of JDBC template. Okay, so this is insert, this is update, and this is delete operation. Okay, so hopefully those are kind of obvious, look obvious too. Okay, so execute. So you can use execute method of JDBC template class, and then basically you're executing this guy, and same thing for this. This is an example. This is an example of invoking a stored procedure. Okay. Okay, so moving forward, named parameter JDBC template class. So this class has support for programming JDBC statement using named parameters, as opposed to programming JDBC statement using only classic placeholder arguments. So the examples we have seen in JDBC is we were using this placeholder question mark, right? Instead, we want to use the named parameters. So in order to do that, you can use named parameter JDBC template class. Okay. Usage of named parameters are supposed to be more flexible, and is actually recommended practice than using those question mark placeholder arguments, because by using named parameters, you have a less chance of making mistakes. Okay, so there are a couple of ways that you can provide the arguments. Okay, so I think okay, so SQL parameter source interface, and there is also I think that's the one that we're actually using here. Oh yeah, so I think yeah, so this is the case that we have named parameter JDBC template. Okay, and so this is an example where the parameter is named as first name. So you are going to use a notation of colon first name, and then you are going to create SQL parameter source object, and this is basically interface, and then there is an implementation class called the map SQL parameter source. So you can actually specify key value pairs. So here this is the name of the parameter, first name, this guy and this guy, and you're actually providing the value of it. And then when you perform the query operation, you are going to provide SQL statement, and then you provide these named parameters. So basically this is replacing the named parameters with so this is basically constructing SQL parameter source object, which is basically in this case map object, where you have name value pairs, key value pairs, and keys are basically in the SQL statement. Okay, so let's do 3 exercises here. So what we are going to do is that, the first exercise, we are going to do JDBC using HSDLQL. So basically, we are going to use in-memory database. And the exercise 2, we are going to perform error handling. Okay, and then exercise 3, we are going to do the same thing using MySQL. Okay, so let's take a look at an example, the lab documentation. Okay, so we are going to run the application. Let me actually run the application first. So we database JDBC named parameter template. Okay, so let's just run this guy. Main application. And result is going to be pretty simple. It will just display, a student that has been just added. Okay, so very simple, but it just verifies that this application works. Okay, so let's take a look at the code. So this is the result you should see. If you see the code, we have data. So this is a package. So it contains the configuration file and main application. And then we have a domain class on the domain package. So we use student domain class. And then we have a repository sub package. So this is, the DAO classes. And we have student repository interface. And then we have a JDBC student repository class that is an implementation of student repository. So student repository is basically an interface where you define the set of database operation methods. So let's take a look at that. So let's Java here, go to repository. If you take a look at the student repository, it's just a set of database operations that you want to perform, like insert, update, delete, find by student ID, insert batch. So you can insert a list of student object, find all, get name, and count all. So this is basically an interface where you have defined the set of database operations you want to perform, and then you can create JDBC version of it. So JDBC student repository is basically an implementation of the student repository. Okay, so later on when you're doing JPA, it's a matter of implementing JPA student repository, and inside you are going to use a JPA. In this case, because it's the JDBC version of it, okay, you can see we are going to perform the JDBC template. So we have a JDBC here. We have a named parameter JDBC template, and then we actually perform update operation. So this insert is from our student repository interface, and the actual database operation is being performed by using JDBC template implementation class, in this case named parameter JDBC template class. So if you go to named parameter JDBC template class documentation, oops, let me just go to named parameter JDBC template documentation, it actually provides a bunch of methods. So if you go to the methods, so it provides a bunch of methods you can call. Okay, so for example, batch update, execute, and the query operation, of course. And then they should be update as well, where you can perform insert and update. And yeah, so this is update. Okay, yeah. So those are the things I actually mentioned in this slide, right? So basically in this implementation class, you are actually performing those JDBC operations using named parameter JDBC template class. Okay, so that's basically what I'm explaining here. One more thing I'd like to explain here is, let me just, yeah, so this, so let me actually explain things from the bottom, okay? So there is what is called the initdb.sql file. So if you go to the resources here, there is a DB directory, and then we have hsqldb, and then we have initdb.sql. Okay, so this is the SQL statement for creating student table. So it will have a student number, name, birthday, grade, and country. Okay, so this is SQL statement for creating table. And you could also have a populate DB-SQL. Here we are not actually populating the table in this example, but if you want to populate any table, you can actually add SQL statement for doing that. Okay, so these initdb.sql and populate db.sql will be executed as part of the application startup. I'm going to actually show you how that is done, okay, in a few minutes. All right, so I just explained the initdb.sql. And then there is a JDBC properties file. So if you go to src main, the JDBC resources, so there is a JDBC properties file. So this properties file will include all the property values that you need for JDBC driver name and things like that. So here we need to specify, JDBC driver name for HSQLDB. So that is the org.hsqldb.jdbc driver. Okay, and this is a URL. Okay, so we are using memory version of HSQL, as you can see. So it's JDBC HSQLDB mem and student. Okay, so that's the database. And JDBC username and password, you're using SA and the password is null. Okay, and you can see we also actually define a property called JDBC init location, which is pointing to that init.sql file that I just showed you. Same thing for data location, which is for populating db.sql. Okay, all right, so yeah, so basically what we need is this. Okay, yeah, so that is basically the information that we need. Okay, yeah, other information, yeah, I should actually comment things out, others, because they are not really needed for this particular sample application. Okay, all right, now let's take a look at the database config.java. This is where things are configured. So this one requires quite a bit of, let's say, understanding. Okay, so first of all, what we need to is student repository object needs to be created. Okay, so remember, we have defined this student repository class. This is a student repository interface, and then we have JDBC student repository class, which is an implementation of this. So we need to create an object of this, right? We need to instantiate that object instance. Okay, so we are going to define right here. Okay, but you might want to in fact say, why don't you do auto scanning? Yeah, that's certainly not an option. Yeah, so we could certainly do auto scanning in our main class, configuration class, main application. Okay, so we can certainly auto scan so that this repository class of this one gets the detected and instantiated. Okay, since we are not doing any auto scanning, we have to declare that the student repository object right here. Okay, does that make sense, guys? Okay, so now here we give a name to student repository. So we are creating JDBC student repository object. So we create the student JDBC student repository object here. Okay, and then we need to set a data source object. Okay, so we are going to call get data source object method. So that is this guy. So when you call basic data source object here, basically this is a basic data source object from Apache, and then here we set the driver name. Okay, so we get the JDBC driver class name from the properties file. So the reason the properties file is specified is here, property source and class path JDBC properties. So remember the JDBC properties file that I just showed you. This is where you are actually defining like a driver class name, URL, username, and password, right? And also JDBC initialization, init location, and dataset location of these things. Okay, so by having this property source annotation, those properties are read by Spring Framework and will be available to you so that you can access those property values, JDBC URL and JDBC username and JDBC password, by using the environment. Okay, so in order to access those property values, you have to actually have environment object to be injected using AutoWire. So that's the way you can access those property files, property values. Okay, so we are going to use environment get property. So this will provide the value of this guy, org.hsql.jdbc driver. So we are basically setting data source object with the driver name and URL and username and password. Is that clear? Okay. All right. So you're basically setting the values of data source object with these values. And then one more thing we'd like to do is we'd like to initialize and populate this database. Okay. So the database is you are talking about is this student database in memory. And that's where we are going to call this guy, create database populator, passing data source object. Okay, so database populator, create database so it's actually this create database populator. That is the method of this guy. So here we get the we are going to actually call, this is kind of, you can think of it as like utility class. Okay, so it's actually getting the init location and data location object. Okay, and then it's actually executing script of this it's executing the init.db.sql and populate.db.sql. Okay, so you can think of this guy as just utility class that is used to execute those the init.db.sql in this application. Okay, so that's basically this one. So we perform the initialization and population of the database tables, and then we return basically a data source object, and that will be actually given basically we are going to get the data source object, and then we are going to set that data source object to this JDBC student repository class. So if you go to the JDBC student repository class here, okay, so we have a set data source method that gets invoked. So now that's the time we are going to in fact create named parameter JDBC template with that data source object. Okay, so now we have a named parameter JDBC template object which contains a reference to data source object, and then you should be able to perform this insert operation, insert batch operation, and things like that. Okay. The rest of it is actually XML version of it. Okay, so this is actually included only for for your reference. Okay, so you can just skip this guy unless you're interested in the writing code in XML. Okay, now let's take a look at the code. So I think I explained these things already. So this is the main application. So we need to import database configuration file. So we import that class, and the first thing we do is basically we create student repository object. Okay, so this is a business logic code. So business logic code just deals with the student repository. It doesn't know how it is implemented, right? So in this case, it is implemented with a JDBC. Okay, but later on you might in fact change to use a JPA, but this code doesn't change because this guy is just using student repository interface. Okay, and so it will create the student, and it will use the insert method of repository object, and this one is using find by student ID method, and you can certainly use other methods of the student repository. Okay, so for your own exercise, I want you in fact call a couple of other methods of student repository here. Okay, maybe you want to create one more student, and you can actually perform other operations. If you go to find the student repository interface, you can actually use find by student. This is what you used. You can perform find all. You can actually call get name. So I try to use a few other methods of this interface in main application as you for your own exercise. Student class is just POJO. There is nothing much to talk about. And repository interface, I talked about that, right? And then I talked about repository implementation. Okay, so it's a matter of, in fact, actually, as you're gonna actually see later on, when you're using basically in this code, database JPA Hibernate engine, we're actually using the same code, but underneath we are just using a different configuration, and we are just using JPA implementation. So in this case, if you take a look at that, on the repository, we actually provide a JPA student repository implementation. All the other code, student and main application, which represent the business logic, it remains the same. Okay, and of course your configuration has to be different. So that's what I meant here in Spring Framework. Changing your database technology from JDBC to JPA, or JPA to Hibernate, or Hibernate to JDBC, these are all very, very simple. Your applications really do not need to change. The only thing that need to be changed is providing different implementation of your repository class. Okay, so either you use a JPA repository class or JDBC repository class or Hibernate repository class or JDO repository class, and then you have to provide the proper configuration. That's pretty much it. So your business logic do not need to be changed. So that's the big advantage. Okay. All right. So this one I actually explained it. Okay, yeah, so you can see these are the implementations of repository interface, but underneath is using named parameter JDBC template, the class. Okay, all right. So for your own exercise, I want you to perform a couple of other methods in the main main application class, and also if you want to add another field, okay, hobby, into the student, and then you need to actually change files accordingly. Okay, so please do those two exercises. All right, so exercise 2 is error handling. So let me actually explain this one as well. So as I said before, one of the advantages of using Spring Framework for data access is that regardless of persistent technology, meaning JPA, Hibernate, or JDBC, you are dealing with the persistence exception classes that are provided by Spring Framework. Okay, so this is an example. So in this case, when you run this application, it will actually cause an exception because you are trying to add the same student twice. Okay, because so there will be an exception because you cannot have duplicate ID. Okay, so let's run this guy first. Okay, so what happens is the first student is added, okay, but when you try to add the same student, then you get the this error code, the error indication. So basically unique constraint or index violation. Okay, so you cannot have the same student twice in a table. So that's basic error condition. So let's take a look at the code. So the code is pretty simple. In our application code, so this is the main application, we have a business logic. When we added the first student, right? And then we try to add the same student again. Okay, so this is the code from previous exercise, and we are going, basically this is added. So we are trying to add the same student, so same student ID 00001, okay? And we actually catch. So we catch the exception using data access exception object. So this is from Spring Framework, okay? Now you can actually get the original exception by calling getCause method. So if you want to find out the original exception, if you want to actually have an access to original exception, you call getCause method of the data access exception object, and this is basically SQL exception. So from the SQL exception, you get the error code and SQL state and get message and things like that. So this is basically to show you still have an access to original exception. But in general, usually you want to actually work with the high-level Spring provided exception hierarchy here. Okay, so that is an exercise. For your own exercise, try to change the initdb.sql. So here, what you're gonna do is check grade is greater than 10. So if grade is set to less than 10, you are going to experience an exception. Okay, so so make sure you have a comma at the end, okay, and then you add this, okay, and then run the application and see whether it is again being catched by data access exception, okay, and then again take a look at the cause of it and what it displayed, okay. Exercise 3 is you're basically using the same code, exactly the same code, but we are going to use a different database. So again, the key point of this exercise 3 is that in Spring Framework, usage of different database is so simple. I mean, it's a matter of changing your configuration file. Okay, so let me actually run this guy. So I'm going to start the MySQL. So if you don't have any MySQL, you need to download MySQL, and then you're going to run MySQL. So I'm running MySQL, okay, and let's make sure. So now let's run the MySQL sample application. So I'm going to run MySQL here, so it should work. And Java application. main application, and this is exactly the same code, except that you're using MySQL, so it works. Okay, and you can actually verify whether that has been there or not. So I'm going to actually use MySQL client. So let me just add another command. So I'm going to use MySQL client shell. Okay, and let's take a look at the databases that are present. Show databases. So you can see I have a test database. Okay, and if you see the use show database, so we are using this test database, show tables. Oh, we have to select the table, select the database. So I skipped this part. So in MySQL, you use test. So basically, you are indicating that you are using test database. Okay, so now I want to see all the tables in the database. So you say show tables, and you can see I have student table here. Okay, so if I want to see all the contents of students, so I can say select star from student table, and you can see this has been added. Okay, so the code is pretty much the same, except that you can see now we are using MySQL settings. So instead of using this is HSQL settings, right? So this is HSQL setting. Now I'm using MySQL setting. That's pretty much it. In order to use a different database, you basically use that particular database settings. Like, so in this case, the MySQL driver is com MySQL JDBC driver, and the database is, again, this is test, right? So MySQL localhost 3306, and you are using test. And I'm using root password, the root as a username, and password is null. Okay, so if you have MySQL running with a different password, you have to change this, you have to set that password in this file. Okay, and then we are using initdb.sql and populatedb.sql. So init db MySQL is pretty much the same. Okay, so here you can see we are using InnoDB engine in MySQL. Okay, all right, so I am going to give you guys about 20 or 25 minutes to perform this exercise. Okay, zoom in. I want to actually explain this guy. So the question was in JDBC student repository implementation class, we have created SQL statement in which we have named parameters like this: student name, the number, name, and birthday, and things like that. So where these values are being set, okay, yeah, one thing I didn't mention was there is in fact what is called the bean property SQL parameter source. What it means is that it's going to use the student object, and the properties of those student object, properties of the student object will be used to set these named parameters. Okay, so we basically, when you call this one passing student, that it actually set the SQL parameter source object with the values of the properties of this particular student object. Okay, and then we're actually passing it. All right, so okay, so we covered JDBC. Now let's move on to OR mapper support in Spring Framework. So by OR mapper, we are talking about technology that could be used to map Java objects to JDBC call, and vice versa. Okay, so Hibernate and JPA or iBaptist SQL maps, these are examples. Okay. As I said, Hibernate as an API is not, it's actually fitting out. So, we're going to mostly focus on JPA. So benefits of using Spring OR Mapper DAOs is, again, easier testing, common data set access exceptions, and general resource management. So all these things basically are configurable, and also integrated transaction management. Your application level will actually use the transaction annotation, and it will use technology specific transaction schemes. Okay, so obviously JPA and Hibernate, JPA and Hibernate, and they use a different transactional scheme. So the persistent specific transactional scheme will be hidden from your application level. Okay, as I said, Hibernate is at least the API, I should say Hibernate API is being deprecated. Okay, so we're gonna actually skip this thing. Let's move on to JPA. Okay, so in JPA, the JPA engine or persistent provider or persistent engine. So I'm using these terms interchangeably. So the JPA engine, persistent provider, persistent engine is the one runtime that actually provides the database operation. JPA is also an API. Okay, so that's something we're going to actually talk about later on. But so you can actually pick and choose a particular JPA engine implementation, and obviously Hibernate could be one of those engines. In fact, that's what we are going to use in our the hands-on lab. And there are other engine implementation, OpenJPA and Eclipse Link. So these are all possible JPA engine or persistent provider that you can plug in. It's a matter of configuration. Okay, so in JPA application, you specify what persistent engine do you want to use. Does that make sense? Okay. Okay, so in XML, this is the way that you can specify your JPA engine selection. So here, if I want to use Hibernate as a JPA engine, then I'm going to use Hibernate JPA vendor adapter, the class. If I want to use OpenJPA as a JPA engine, then basically I'm using OpenJPA vendor adapter object. Okay. We're going to actually take a look at the Java configuration as well. So Spring JPA support offers three ways of setting up JPA entity manager factory that will be used by application to obtain an entity manager. Okay, so local, the entity manager factory bean, obtaining entity manager factory from JNDI, and local container entity manager factory bean. So we're gonna actually take a look at a couple of these things. First, the last one is the most powerful version, local container entity manager factory bean. So this is used for full JPA capabilities in a Spring-based application environment. So it allows a fine-grained customization, and then you're going to select the JPA engine in here in Java configuration. So when we created a local container manager engine, local container entity manager factory bean object, so we create one first here, and then we set the data source object. Okay, by calling get basic data source method. This is the same method that you've seen in JDBC layer. And then we are selecting Hibernate as a JPA engine. So this is basically a selection of JPA, a selection of Hibernate as a JPA engine. So here we are creating Hibernate JPA vendor adapter object, and then we are going to set that up here. So we call set JPA vendor adapter method, passing that particular vendor adapter object. So if I want to use something different, OpenJPA as a JPA engine, then basically I'm gonna create the new JPA vendor. The new OpenJPA vendor adapter object, and that's the one that you can actually pass to the set JPA vendor adapter method. Does this make sense? Okay. Okay, so DAO implementation. So in your DAO implementation, so in our JDBC case, we have a JDBC student repository implementation implementing student repository, right? And then we were using the named parameter JDBC template class. Here we are going to use entity manager class. Okay, so that is from our JPA specification. And in order to get entity manager to be injected, you are going to use @persistence context annotation. So when you are using these two lines of code, you are asking JPA, you are basically asking the runtime environment, here in this case is Spring Container, to find the entity manager class and create an instance of it and inject it here. And then you should be able to use entity manager to perform database operations. So you can actually call the persist method, find method, and create query method and all that stuff. Does this make sense? Okay. Okay, so let's do exercise 7. Joel, can you go over transactional here? Transactional here. Yeah, we're gonna actually talk about transaction things in our next presentation. For now, you can just assume, a transactional notation is used to make that class or the method to be transactional. Okay, so but we're gonna actually talk about that in detail later on in another presentation. We have a whole presentation dedicated to transaction. Okay, so let's take a look at the exercise 7. Yeah, we're gonna skip 4, 5, 6 because those are all Hibernate things. So here, exercise 7, we are in fact using Hibernate as a JPA engine, but we are using JPA as a standard API. Okay. All right. Question from Rokesh. Question is, what is the significance of persistence.xml file? Yeah. So in JPA, a persistence XML file is in fact where you can specify the persistent engine. Okay, but we are not using persistence.xml file here, and because we are actually using the configurations. Okay. And the latest version of JPA does not require the persistence.xml file either. Okay, so basically, persistent.xml file has been used to specify the persistent engine of the JPA, and also you specify domain classes as well. Again, we are doing those things through the programming API. So that's the reason in our sample applications we actually do not need to have a persistent.xml file. Okay, all right, so let's move on. So here, let's actually run the application, and it should actually run exactly the same because we are basically using the same code. We just happen to use a different, the persistent API and different technology. So I mean, that's the beauty of it. Your code don't need to be changed. Your code basically working with the repository interface, and everything data storage access is concerned, everything that is related to data access storage is concerned, is hidden in that repository implementation class. Okay, so it's gonna result in the same code, the same result. Okay, so same result. Okay, and that's a good thing. Okay, so let's take a look at the code. As you can see, the only difference here is that we now use a JPA student repository.java instead of JDBC student repository Java, and of course we're going to have a different configuration in database configuration. Okay, and here we initdb.sql and populateDB.sql, those are the same. Okay, and we also have a JPA property, so we decide to separate out any JPA specific properties into its own properties file. Okay. All right, so let's take a look at each of this. So let's take a look at the configuration first. Okay, so here we are using local container entity manager factory bean, and we create that object, and we set the data source object by calling. So again, get basic data source method. That is pretty much the same thing that we have seen in JDBC. Okay, it's the same code. And then here, this is the code that we are setting Hibernate as the JPA engine. So we created Hibernate JPA vendor depth object, and we just set a couple of things. So here, this is the if you want to see SQL statement, you set this one to true. Okay. And if you do not want to see the SQL statement, then you set this guy false. Okay, so we now set to true, so you will actually see when you run the application, yeah, in fact you see all the select statement. These are all select. Let's actually show, let me actually show you. So these are all Hibernate. These are SQL statement, you can see. Okay, so this is insert and then select and then select. Okay. All right, so you can see the reason is because we actually set this show SQL to true. Okay, so this is for creating Hibernate as the JPA engine. Then we set a couple of options for that Hibernate behavior, including show SQL. And then we so this one, one of the reasons why you're using persistent XML file is to specify all the domain classes in there. Okay, but since we are using scanning, so basically scan the package to find all the domain classes. Since we are using this guy, we don't need to have a persistent XML file. Okay, and then we actually setting some properties. We create a properties object, and then we set the hibernate dialect. Okay, so here you can specify, I'm using MySQL dialect or HSQL dialect or the MySQL dialect or whatever. Okay, and then in this case we are also setting some like generate statistics, show SQL, and things like that. Okay. And let's see, yeah, that's pretty much the the guts of it. Okay, so that's the configuration. And in terms of the repository, JPA repository implementation class, we get the persistent context, we get the entity manager through persistent context annotation, and then all this interface method like a store, delete, find by ID internally is using entity manager object. Okay, in JDBC case, we were using named parameter JDBC template object, right? Here we are using entity manager object. So, anything that is really related to database access is hidden in this implementation. So it's a matter of actually using particular implementation class, repository implementation class in your application, while your applications are hidden from all these low-level details of data access. Okay. All right, so that is that, and let's see, the homework. Yeah, so I'm gonna let you do this homework a bit. The homework is create a new project that use JPA. So you are going to copy the database JPA Hibernate engine project, okay, and then create another project, or you can just change it directly if you want to. So create a domain class called the account and should have a name and balance. And create all the necessary files as in the case of the project, and in the main application create 3 accounts and update the second account and delete the third account and list the remaining accounts. Okay, yeah, so that is the exercise that I want you to do on exercise 7. All right, so I'll give